Alright, girls. So now let's do a revision on section 2.3. You have learned in Form 3. So this section is about angle in the alternate segments. Alright, so firstly, let's learn some definition. So firstly, I should introduce a kind of angle for you. So here it is given that BC, okay, BC is a tangent to the circle at point T, okay, point T is the point of contact, and AT is a chord, okay, AT is a chord, so the angle formed by tangent and chord is called tangent chord angle, okay, very simple. And similarly, angle ATC, okay, angle ATC is also a tangent chord angle, is also a tangent chord angle. All right, so this is the first concept you should know, tangent chord angle, okay, very simple, a tangent and a chord form an angle, so it is called tangent chord angle. All right, and then another one is here you see that chord AT, okay, chord AT separate the circle into two parts, okay, into two parts, and this is a segment, and this is also a segment, okay. And here we have another name for the two segments. All right, for the red one, okay, for the red one, this segment is called the alternate segment of angle ACT, okay, so alternate, you see it is not on the same side, alternate, you know the meaning of alternate, okay, so alternate, okay, so here you can see that angle ATB, okay, the red segment is called the alternate segment of angle ACT, and similarly, the blue segment, okay, this segment is called the alternate segment of angle ATB, okay, so this segment, okay, is an alternate segment of who? Of angle ATB, okay, so alternate, okay, so corresponding to an angle. So when you say alternate segment, it means that alternate segment, you have to say which angle, okay, so it should corresponding to an angle, okay, so alternate segment. So this is another concept, okay, alternate segment, okay, you should know. And the last concept you should know is the just now you know that this is an alternate segment, okay, this is an alternate segment of angle ATB, okay, alternate segment of angle ATB. So the angle in this alternate segment, for angle ADT and angle AET, okay, these two angles are called the angles in the alternate segment of angle ATB, okay, so usually we would just say angle ADT and angle AET are angles in the alternate segment, but for corresponding to which angle? Corresponding to angle ATB, okay? So similarly, in this alternate segment, an angle AHT and angle AFT are also called, these two angles are called the angles in alternate segment of angle ATC, okay, corresponding to this one, okay. So here we introduce the third concept, angle in alternate segment, okay, angle in alternate segment, it is just the angle in the segment, okay, but the segment is corresponding to an alternate angle, okay. So here we just say this segment is the alternate segment, okay, corresponding to an angle, okay. So here it is alternate angle, okay, angle in alternate segment, okay, angle in alternate segment. All right, so now let's do some practice. So in each of the following figures, PQ is the tangent to the circle at point T. Mark an angle in the alternate segment corresponding to angle X, okay? So mark an angle in the alternate segment corresponding to angle X. All right, so angle X here, angle X is the tangent chord angle, okay, tangent chord angle, and this tangent chord angle is corresponding to an alternate segment, it is this one, okay? So the angle in alternate segment is angle TAB. So it should be angle TAB, okay? So angle TAB is corresponding to angle X, all right? And here, angle X is also a tangent coangle and is corresponding, okay? Is corresponding alternate segment is this one, okay? Is this one. And the angle in alternate segment, what it should be. So actually here, it doesn't give us the angle directly. So actually, it should be, okay? It should be here. So the angle in alternate segment, so this angle, okay? So the angle should be, sorry, here actually it's given, okay? It is angle ABT, okay? Angle ABT is corresponding to, okay? Corresponding to, okay? So for this arc, okay? For this arc, okay? For this arc, sorry, for this core, and this is the alternate segment, okay? So the angle in alternate segment is this one, okay? So angle ABT, okay? Angle ABT. But actually here we have one more angle is also angle in alternate segment, which is angle ACT, okay? Angle ACT, all right? So angle ACT is also the angle in alternate segment corresponding to X. And the last one, okay? The last one, so the alternate segment is this one. So angle TCB, okay? Angle TCB is the angle in alternate segment, okay? So here it is not a good way for us to identify the angle in alternate segment. So here I introduce a way for you to identify the angle in alternate segment, okay? So actually, focus on the tangent coangle, okay? Focus on the tangent coangle. And inside the tangent coangle, there is an arc, okay? There is an arc. And the angle at circumference, subtended by the arc inside the tangent coangle is the angle in alternate segment. So here I use an unknown y to represent the angle in alternate segment. Okay, so y is the angle in alternate segment. So similarly for this one, so the tangent coangle is this one. Okay, and angle inside the tangent coangle is arc AT. Okay, it's arc AT. So arc AT subtend to angle ABT. Okay, ABT. So angle ABT is the angle in alternate segment. And lastly, so the tangent coangle is angle PTB, okay, PTB. And inside the tangent coangle is arc TAB, okay, it's arc TAB. And arc TAB subtend to angle TCB, okay, TCB. So angle TCB is the angle in alternate segment, okay? So when you identify the angle in alternate segment, you may identify the arc, okay, the arc inside the tangent coangle, okay, tangent coangle, okay? So we just identify the arc inside the tangent coangle, and then the angle at circumference subtended by the arc inside the tangent coangle will be the angle in alternate segment, the corresponding angle in alternate segment. All right, so this is about the angle in alternate segment. All right, so now let's look at part B, a theorem, okay, theorem 2.5. So theorem 2.5 tells us that a tangent coangle of a circle is equal to an angle in the alternate segment, okay? What does it mean? It means that the tangent coangle, this is a tangent coangle, the tangent coangle equals the angle in alternate segment, okay? So it means that the angle at circumference, this is the angle at circumference, subtended by the arc inside the tangent coangle, are equal, okay? So equals the tangent coangle. So similarly here, this is a tangent coangle, and it equals the angle subtended by the arc inside the tangent coangle. Okay, so we identify the arc. Okay, so here this is a way for us to identify the tangent coangle and also the angle in alternate segments. So here the theorem tells here is the meaning of the theorem. Okay, tangent coangle equals angle in alternate segment. Tangent coangle equals angle in alternate segment. Okay, so the short form of the theorem is called angle in alternate segment. Okay, the theorem is angle in alternate segment. So angle in alternate segment, the theorem tells us that angle tangent coangle equals angle in alternate segment. Okay, equals is corresponding angle in alternate segment. So please know that. Okay, the corresponding angle in alternate segment. So now let's try to prove this theorem. Try to prove this theorem. So actually, this theorem, the given condition is a tangent coangle and also angle in alternate segment. But how can we prove these two angles equal? How can we prove these two angles equal? So firstly, the given condition should be PQ. Okay, PQ is a tangent. Okay, means that PQ is a tangent to the circle. Okay, to the circle at point T. Okay, so this is a given condition. And then if we have a tangent, and then we will have a tangent coangle, and also correspondingly we will have an angle in alternate segment. All right, so let's try to prove prove angle A, and then we prove how. Okay, so this is a given condition, okay, and prove, okay, the given condition, prove angle ABT equals angle ATQ. Okay, so this is the result of the theorem. So now let's see how to prove it. So when you see a given condition that is a tangent, there's a tangent, so you have to recall some properties about tangent. So actually in section 2.1 and section 2.2, you have learned some properties or theorems about tangents. Okay, about tangents. All right, so actually a very, very important theorem you have learned is called tangent perpendicular to radius. Okay, a very useful and also important theorem is called tangent perpendicular radius. So now PQ is a tangent, and here we do not have a radius. Okay, we do not have a radius. So if I join OT, okay, join OT, because T is a point of contact, so OT will be the radius, okay, the radius, and then I extend, okay, I also extend OT and meet the circle, suppose at point D, okay, at point D, and by tangent perpendicular to radius, okay, by tangent perpendicular radius, we will have 90 degree. Okay, so here we have 90 degree. Okay, 90 degree, and here you see that I extend TO and meet the circle at point D, and TOD is the diameter of the circle. Okay, so when you see diameter, and one of the theorem you can recall is that angle in semicircle, right? Angle in semicircle. So it means that if you have a diameter and then you can join BD and then form an angle which is 90 degree also. Okay, 90 degree also. Okay, so now here we have 92 angles which are 90 degrees, and then you see that angle DBA, this angle DBA and angle DTA are subtended by the same arc. Okay, subtended by the same arc, and both of them are angle at circumference, so they are equal. So if I let them be alpha, and these two angles are equal, and just now you know that angle DTQ 90 degree. Okay, 90 degree. And this angle is also 90 degree. Angle DBT is also 90 degree. So correspondingly, angle ABT, the angle in alternate segment will be 90 degree minus alpha, and angle ATQ is also 90 degree minus alpha, okay? So now we see that the tangent coangle equals the angle in alternate segment equals 90 degree minus alpha. So we prove this theorem, okay? So this is analysis. So now let's try to organize the proof, okay? So let's see. So at the beginning, so we have to construct a line, okay? So join OT, okay? Join OT and extend OT or extend OT and meets the circle at point D, okay, at point D, okay, at point D, all right? So and then, okay, and then join and also join BD, okay, join BD, join BD. So now let's draw the graph again. So extend join OT and then extend it, okay, and then here is point D and this is join BD, okay. So now now we can write the result, okay. So OT or DT, okay. So OT, okay, OT or maybe DT perpendicular, okay, or maybe I write tangent first, okay, tangent first. So because PQ is the tangent to the circle, okay, to the circle. This is a given condition, okay, this is given. So DT perpendicular to PQ, okay, PQ. So the reason is tangent perpendicular to radius, okay, tangent perpendicular radius, all right. So it means that angle DTQ equals 90 degree, okay. So actually from perpendicular and then we get the angle be 90 degree. This is just the basic definition of perpendicular, okay. So here it is easy to find angle DTQ is 90 degrees, so you have to write out, okay. So and because DT is a diameter, okay, is a diameter, okay. So and then we can have angle DBT equals 90 degree, okay, equals 90 degree, okay. DBT is also 90 degree. The reason is angle in semicircle, okay, angle in semicircle, all right, angle in semicircle. And after that we should prove these two angles are equal, okay. And because and then angle DBA equals angle DTA. The reason is angles in the same segment, okay, angles in the same segment, okay. So it should be angles, okay. You see there are two angles, okay, of course the angles in the same segment, okay. And let angle let one of the angle be alpha, let angle DBA be alpha. So angle DTA is also alpha, okay. And then after that, so we can get that angle ABT equals angle DBT minus angle DBA equals 90 degree minus alpha, okay, minus alpha. And angle ATQ equals angle DTQ minus angle DTA equals 90 degree minus alpha also, okay? So this is 90 degree minus alpha. This is 90 degree minus alpha, okay? So you see that both of these two angles are 90 degree equals minus alpha. So angle ABT equals angle ATQ, okay? So this is the result of the theorem, okay? So we prove the theorem. So here, you have learned the theorem. It means that later, when you see a tangent to the circle and identify the tangent coangle, and then the tangent coangle will be equal to the angle in alternate segment, okay? So up to now, you can use this theorem, okay, and to solve some problem, okay? So it is very convenient to use this theorem to solve some problem. All right, so now let's look at some practice, okay? Quick practice 2.9, okay? Quick practice 2.9. So let's look at the question. In the figure, PR and QR are tangents. All right, given condition, tangents to the circle. So PR at point A and point C. Okay, so these two are tangents respectively. So angle PAB is 75 degree and angle BCQ is 33 degrees, okay? So now let's try to find angle ACB and angle ACR. So given tangents, so we have to recall some properties about tangents. So just now we just learned a new theorem, which is called angle in alternate segments. So we identify the tangent coangle, okay? And this is tangent coangle, and the corresponding angle in alternate segments. So we identify the arc inside the tangent coangle, and it subtend to angle ACB. So then this is 75 degree also. And another one, angle BCQ is a tangent coangle, and inside the tangent coangle is arc BC, and arc BC corresponding to angle BAC, which is an angle in alternate segment. So this angle is 33 degree, okay? So by angle sum of triangle, we can easily find angle ABC, okay? Angle ABC, okay? So here we use angle in alternate segment 2 times, and then we use angle sum of triangle to find angle ABC, okay? And how about angle ARC? So angle ARC is here, okay? This is angle ARC. So if you want to find angle ARC, so it is better to find angle RAC and angle RCA, okay? Angle RCA. So how to find these two angles? Actually, as you know, angle RAC is also a tangent coangle, and it is corresponding to angle ABC. Okay, just now we know angle ABC, and also angle ACR is also a tangent coangle, and this arc is corresponding to angle ABC also. Okay, so it means that angle ABC equals angle RAC equals angle RCA, okay? So it is very easy to find angle RAC and angle RCA, okay? And then using angle sum of triangle, we can find angle ARC, okay? So this is the way to prove this, to find angle ABC and angle ARC. All right, so now let's try to write out the steps, okay? So when you do the question, it is better to analyze the question like this, okay? So draw some, find out the given condition, okay? Highlight the given condition. All right, so now let's organize the step, okay? Solution, okay? And just write because PR and QR are tangents, okay? Are tangents, okay? So this is given, okay? Given are tangents. So we can get that. So angle PAB equals angle, the alternate angle. So angle ACB equals 75 degree, and angle directly I also write together. So angle BCQ equals angle BCQ equals angle BAC, okay? BCQ equals angle BAC, okay? BCQ, all right? So equals 33 degree, okay, equals 33 degree. The reason is angle, I write in the middle, okay, so both of them apply this theorem, okay, so angle in alternate segment, okay, angle in alternate segment, okay. So after that, in triangle ABC, okay, in triangle ABC, angle BAC plus angle ACB plus angle ABC equals 180 degree. The reason is angle sum of triangle, okay? So we have 33 degree plus 75 degree and then plus angle ABC equals 180 degree. So angle ABC just equals, okay, ABC just equals 180 degree minus 75 degree minus 33 degree. So it will be the answer 180 degree. So it is 72 degree, okay, 72 degree, okay. And then question B. So question B, just now we have analysis. So use angle in alternate segment, okay, also. So angle RAC equals angle RAC equals angle ABC, okay. Angle RCA also equals angle ABC, okay. Equals. So the reason is angle in alternate segment, okay, angle in alternate segment. So in triangle ARC, okay, in triangle ARC, angle ARC plus angle ABC plus angle angle RAC plus angle RCA, okay, angle RCA equals 180 degree. So substitute the angle RAC and RCA, both of them equals angle ABC, which is 72. So angle ARC plus 72 degree plus 72 degree equals 180 degree. So finally, angle ARC equals 36, okay, 36 degree, okay. So here I forget to write out the reason, angle sum of triangle, okay, angle sum of triangle, okay. So this is the complete proof or a complete step of question Quick Practice 2.9, okay. So now you may have a break.